Hello and welcome everyone. This is the second stream where I'll be live coding project Apicula stuff. Today my plan is to add a new primitive to the chipdb. I have this little sort of things that have to be done here. So at the moment basically it only supports basic LUTs, flip-flops and IO buffers. But some of these logic slices can also be used as ALU, which means that there's a hardware carry line. So I'll try to figure out how these things work and how to use them. And the sad part of the story is that we can't actually integrate them into the next PNR thing that we have now, because that only supports really the basic logic slice and not any carry things. But yeah, let's see. First I'll show, okay, let's see. First I'll show kind of what I have and what I want to add. So currently there's this chipdb which from the vendor files loads the lookup tables and wires. And then this fuzzer adds data flip-flops and IOB. And here I want to add a fuzzer for the ALU part. So let me first show, sorry my throat is a bit annoying today. First show what I know basically. Because there's these vendor files of course, and let's see. Yeah, so I think in the that file, which it converted to JSON, there was some ALU, yeah, here, ALU. So let's see what that is about. ALU in. Ooh, interesting. That's not quite what I expected, to be honest. Yeah, so I mean there's parsers for all these files, but doesn't mean the meaning of all the data is known. So I mean this could be anything basically. This could be the bit of the input, or it could be a wire number, it could be many things. What else do we have? Is there anything in this ALU that is what is DLT even? So one thing, I'm not sure why there's so many rows here, because ALU sort of coincide with the LUTs. So there's 8 of them in a tile. So you would sort of expect, like if there were sort of numbers from 1 to 8, that would be a sign that, you know, they're sort of index of the, I guess there are numbers from 1 to 8 here, or not quite. 0, 1, 2, 3, 4, 5, 6, 7, 8, yeah, kinda, not really, but it's 0, so it's Um, confusing. Okay, let's leave this aside for now. I mean, if anyone has questions or ideas, just shout in the chat and whatever. Another thing you can do is just let's see. No. Here I have these old scripts that use TCL API to just generate some stuff. So what I'll just do is have the vendor tools generate an ALU and see what comes out, just to get an idea what we're looking at. ALU, and then there's a TCL script, and this basically tells the vendor tools what to do. So it just adds this file configuration and runs the PNR basically. So let's see. I need to change this to have an ALU, and I will copy this from Yosis has in the Gowin support. Yeah, this one. Does it have ALU? No? Why not? Scope table. Somewhere else, I guess. Oh, arith map. That sounds good. Yeah, so ALU gets mapped to this. So I'll just put this nice indentation there. Let's say we just what's going on here? I'm not really very good at Verilog, so I guess this is a parameter and this is the name of the thing. Oh yeah, so these are the, okay, so I'll just make some wires for IO and I1. Oh, I0, I1, I3, no I2. Yeah, thank you. Yes, this I3 wire is sort of it does some special stuff in some modes. Something like this, and then let's see, BPD, and then run it. Go in. Where's that? IDE, I guess. Go in shell, and then you just give it run TCL. Uh-oh. Syntax error near token. That is I guess, okay, let's wait, let's see. You have a different syntax for parameters, I guess. Like, yes. this. Yeah, here, see. So I guess we need to do ALU mode. I will stick to 2 because that's what we have here. Yeah, so they're, you know, the Verilog parser of the PNR thing is not very flexible. You have to really give it warning. ALU blah blah. Okay, but it did work. Oh no, it did not work. Fails to place with. Okay, so it did not work. Oh yeah, you have to. I don't know why it didn't work. Where's the CST file? Ah no, there's no CST file because it's empty, but in the LUT one there should be, yeah, see, LUT for CST give me thank you. Now this is tricky because I don't know where the ALUs can even be. It's something we have to figure out as well. Actually might have to do that first. Can we get the floor planner to do this for us? Actually, let's try this. Floor planner. Sure, design file. We'll give it our empty file and say, okay, it's for Gowin R9. Because I don't think the Gowin 1 even has ALU tiles. Doesn't matter so much. There you go. Primitives, ALU. Where can it go? It can't go everywhere. Okay. That's interesting. Let's just see if it works if we do this. Because what makes me think it might not go everywhere is there's basically all the tile types from 12 to 17 are different basic logic tiles basically, and some of them have like memory in them, or and I figure there might be a particular kind that has the ALU, but I guess maybe it's just all of them. Okay, let's just try. So we have to add the CST file, and I forgot how to do this. This should help. Yeah, see? CST. Now, please do this for me. It actually worked. That is nice. Okay. This is interesting. Okay, let's see what it produced. This is like, oops. There you go. read bitstream from yep. Okay, so with bitstream and then the commands that came with it. We don't need them, but and then we can say, okay, I want to just display this bitstream. No, it takes file name first. So we say ALU .png bitstream. Let's see, ALU.png. Okay, so we placed it there in the top, and yeah, so this is sort of the lookup table and the flip-flop and some other bits. Now I don't know exactly what, like there's this one pixel, two pixels. Oh, okay, maybe like this is one lookup table and this is another one. So apparently it has used two. That makes sense. And what are these? Okay, so what you can do is the parser for the views file has some actually there. No, let's go in one. No, okay. R9. Oh, where? 9 R9. There's functions for finding all the fuses. Here, scan fuse, scan table. Let's see. So we have to tile the bitmap. I forgot which order to do them off the top of my head, but yeah, you have to first put it into tiles. You can either parse the tile, which will only look in these things, or you can scan all the tables and just look for random stuff. But let's see what happens if we just parse the tile. Yeah, whatever, it doesn't matter so much. Tile bitmap with the bitstream we got. What else does it take? It takes the views file and the bitmap. What do we have? This is our yeah, the tile we're looking for. Because yeah, the floor planner is 1 base and this is 0 based. So we put it at 2 2 and now it's at 1 1. So we can get this tile out. 16. Okay. And then we can say parse tile with this is tile type 16 apparently, and the tile, and will give us all these fuses of the fuse file. So 25, this is a flip-flop. 26, 27. 5 is the LUT bits. So yeah, it has so this is like sort of LUT, number, and index. So it has all these set. That's actually weird. So it has all the bits in this one set, and all the bits in this one set, and it has all these wire bits set. This is super weird, right? Because this one has these bits set, and I don't see these at all. Wait, how many bits are this? I'm gonna open this in a program that doesn't do this annoying blurry thing, like G. This makes it a bit more easy to look at, I guess. Don't need a huge ass brush, thank you. 1, 2, 3, 4. Yeah, so this is one full lookup table basically, and it's all ones. What is the purpose of a lookup table that's all ones? And this is only 2 entries, which is also very strange. So what if we change the mode of this thing? Say we go, I don't know, set the mode to 5. I don't know what it does, but just see if it changes something. Okay. Read that. And then write that. Sure. It's exactly the same. What is going on? That doesn't make sense, does it? And what are these bits? That is strange. because if you look at where can I show this? Yeah, exactly here. You have like this lookup table and the flip-flop bit, and then all these wires. So somehow it's these two bits, they're probably connected to a wire somewhere, like correspond to something here, which is also what we saw in the parsing the tile. It finds some wire here. Not sure what's going on here, to be honest, because it seems to be finding lots of bits that I don't think are set at all. Yeah, not sure what's going on at the moment. One other thing I thought could be relevant is this file has this tile grid. This thing, yeah. IPython likes to format everything nicely for me, which is not very helpful. Let's see. Whoops. There. Yeah, so you see it's like 16, 16, 16, 12, 12, 12, 17, 17. And I'm wondering if you look at, say we look at 12. It has wires. Yeah, 2. And now I'm wondering here, so there's these carry in and carry out wires, and you would expect these to be part of the ALU, right? So I'm thinking like one of these wires in all these tiles should be the ALU CN thing. So let's say we want to know which wire is carry in null. 303. So let's say we look in this table and just flatten the whole thing. Wire for row in this thing, and then for I want the first two, which are the actual wires, and the other ones are fuses. that will give all the wires, and then we can say is 303 in here at all? No. So 12 doesn't have any carry wires, which is strange, right? Because we just placed an ALU there. So, huh? What did we have? We have 16? No, also not. Okay, just let's try them all. 15, 14, 15, 16, 17. I think that's it. I think it doesn't go any further. Yeah, there's no tile 18. Okay. So basically, none of the logic tiles even has a carry in and a carry out. Huh? Yeah, that's not expected. So what is going on here? We have a lookup table that's all ones, a lookup table that's almost empty, and 2 bits. That makes no sense at all. This is a lot more confusing than I expected. Well, except confusing is kind of what I should expect, I guess. This should make some difference, right? Doesn't make sense. No. I think the other one at least reloads automatically, which is convenient. No change. I remember that. Okay, let me show this to you. What this is all the documents of Gowin. I have this primitive user guide. Ching. And in the, let's see, ALU, ALU. They have all the modes here. ALU mode, add sub, add sub. So I just change it to 1, which is sub, which should invert the B input, right? So I run it again. Display. Oh, close it. And it's the same. Why? Okay, maybe I should listen to this warning and give it a carry input. let's see. So they have these, where can I get this from? They have this VCC primitive to give like a 0 or 1 input, which I will steal from I'm sure I have it somewhere. Can I just grab? Yeah, the unpack produces this. There you go. So say the carry in, we just put it to VSS. That should get rid of the warning, I hope. Okay, better. Hey, it's different. Ah, okay, this kind of makes sense, but also not. What the fuck? Sorry for cursing. So I'm guessing this here is the carry input multiplexer. Which is now connected to ground, which makes sense. Except now both lookup tables are just 1. Which just means like whatever input you give it, the output will be just 1. So that's not a very good ALU, right? What is going on? Still, just nothing. Interesting. So let's look at what bits these are. I want to figure out these wires, I guess. And I should be able to just use the new ChipDB stuff for this, rather than the scan table stuff. But I think this is just a normal wire. Well, I can just try. Where do we have this? The tile. Whoop. That's not very helpful. Okay, let's see. Let's just run the unpacker on this thing, shall we? T. Yeah, so it found indeed 2 full LUTs and just the default flip-flop that comes with any LUT. But that's if I just say, oh, let's just print all the wires as well, and then if we reach the column of interest, the tile of interest, I'll just put a breakpoint there. Why not actually? Just all the things. Let's go. Right. So this is the LUTs in the flip-flop. This is the wires that we're seeing. Okay. Bips. So what we want is we set it to VSS, right? Yeah, so we want somewhere too much. The thing is, like empty, like the default muxes also have a direction basically. So like every single mux in this tile has something set. But you expect that I don't see VSS or ground anywhere, right? Very strange, very strange. Okay, so what if we, because now we're just, making a bit stream or like a netlist by hand, which I don't know, I have the feeling this is just, it's just not correct. Like this doesn't make sense in any way. So what I'm thinking is like just write a simple Verilog, normal Verilog program that adds 2 signals, and then give it to the vendor tools and say, hey, just do your thing and generate like a proper program with wires and everything, and then maybe we can see what happens to it. Like maybe there's no actual ALU at all, and it all just gets compiled to normal LUTs and things. Maybe there's no hardware carry at all. That would be strange, but who knows? Or maybe they're hardwired, like a series of mux, like the carries just like are hardwired to the next LUT. So if you just put them in the correct order, it will function as a header or something. I'm not sure if I'm making sense at all. Let's just try, see what happens if we just like put an actual program in the IDE and run it. Do we have the IDE running? No, just the floor planner. Go by floor planner. Okay, new. Put it somewhere, I don't care. Here. Okay. Yeah, let's do it Gowin one. Why not? Okay, go, good. How to Verilog. Let's see, so I have an input A and B. Let's make them like, no, should be fine, I guess. How do you make a 1-bit input? Is that like this or something? I think Verilog wires are kind of, you know, they just change to whatever you want them to be. I have no clue what I'm doing with this. If anyone knows any Verilog in the just put some stuff in the chat, because I have no clue what I'm doing here. Let's say we have a 2-bit output for no good reason. Would that's all work? No. Oops. You can't assign a pack type to an unpack type. What does that even mean? Oh wait, that doesn't make sense. Happy? Happy, okay, good. Let's see the netlist, what it produced actually. Output, okay. You see, that's this. It doesn't use an ALU at all. Interesting. That's not what I want though. Maybe it has to be, you know, not tiny for it to make an ALU. We'll see. Input buffers, output buffer, ALU, there we go. This looks better. Okay, let's try what we get. Nice. Cool. And now we run the unpacker on this. And first let me unbreak it. put it even. Test. Implementation, PNR. Not test, but FS. Ching. Uh-oh. Ah, yeah, we did it for Gowin 1, right? My bad, my bad. Happy now? Okay. That is... Oops. That's not good. Okay, but this is another problem than that what we're trying to solve currently. Yeah, we don't care about this for now. Do we? I don't know. Yeah, I do care about this for now. I guess I'll just have to... Oh no. Oh no. Just don't do IOB for now. We'll fix that later. There you go. It's a bit much, right? Let's see. Can at first just look at the... Oh, yes. This will take a while probably to generate actually, but meanwhile, let's see. Yeah, okay. Nope. Oh, LUT test. What did I call it? LUT test. Wet. Okay, interesting. I guess this is all these wires to all the IOB. And this is where the fun begins. Oh, actually, see this? This looks familiar. I guess these are, there we go, okay. These are the actual, 1, 2, 3, 4, 5, 6, 7, 8 actually used LUTs, and this is the magic weird one or something. Let's see. Oh no. Painful, painful. Where are the actual useful bits? There you go. Yeah, so we deleted the IOP here because there's bugged somehow. Yeah, so it just decodes fine as, LUTs. We had 9 LUTs, right? Yeah. Let's look at that. Let's look at what's inside these. Yeah, so there's our interesting lookup table. What I want to know is these are all the same, right? Yeah. Like, what does this represent, this lookup table? If you just make it into like, so try to reverse engineer what is the function of this thing. If it's like, I mean, I suppose it's an adder. But like, there's no carry here, right? So it's just I guess it's sort of like an XOR maybe. Would that make sense? Like bit 1, bit 2, bit 3 has 1 and 2 both set. And this is sort of bit 3 set. If it was it was like a 4 input XOR, that wouldn't work. So let me, what's the truth table for a full adder? Does that look anything like this at all? Not really, right? Not at all, actually. Ah, hey, what if input 0 is not used? So it's like inverse of that, I guess. So it's like 0, 1, 0, 0. Yeah, so what? 0, 1. No, it doesn't make sense either. Makes no sense either. I have no idea. Okay, let's just leave that for a while. What do you have now? Where are we? What can we do? So yeah, it seems like the first LUT in the carry chain kinda is just all ones for no good reason at all. And then there is these things, and these are not, they don't seem to be half adders or anything, full adders or whatever. Actually, or are they? What's a half adder? This is like, yeah, that's just XOR, right? Yeah. So you'd expect 0, 1, 1, 0, which is not what we see, right? Not at all. It seems. What is strange lookup table? It could be that they reordered these inputs, right? Would that change anything? Because as you might remember, in the, still have it open somewhere. Yeah, it was like input 0, input 1, input 3. So there's no input 2. So I mean, so what if we say, okay, this input 1, input 0, input 1, this one is not used, and this one is the carry or whatever it is instead. No, wait, there's a carry in, and there's the third input, which is sometimes used. Is the It's not even like repetitive, right? It's not like the lower part is a copy of the upper part. Because it's 16 bits, so you'd have 8 lower bits and 8 upper bits. It's just not the same. Okay, so now if we change it, does it actually change? Like if we now say subtract, does it actually make a difference? See, so yeah, done. Unpack the thing. Hey. That is definitely different. That is definitely different. Okay, let's see. Compare. Jing. These are again all the same. So what you expect of sub is normally that you have basically A plus invert B plus the carry. So the carry should be different, but in terms of like the dot bits, you would expect all the B bits to be inverted basically. So that would be this one, this one, this one, this one. Is there any pattern in this that I can recognize? Let's see. Different. I can just go to manually XOR the two. That makes no sense either, right? Like if it was every fourth bit or something, you could say, oh yeah, this is the B wire. But no, it's just different. Alright. So okay, I have no clue. I guess this is why it takes a long time to document an FPGA, because every step along the way is just, huh? What? What? So what we could potentially do is just ignore this. Just write a fuzzer that finds the bits and say, okay, this is the ALU now. Don't care what's inside. And do this for all the modes. The only thing that causes problems there is, this first lot doesn't make sense to me. It's like it's all ones, except for this bit. So I mean, if you would just fuzz, one a 1-bit ALU, as I tried to do before with this empty thing, you just get this thing always. It's only when you add additional bits that you get more of these lookup tables. So it's not trivial to just fuzz a single one. And also, we haven't really figured out what happens with the carry, because as far as I know, this LUT only has one output, and the full adder has 2 outputs, carry and sum. So for it to make sense, there has to be a carry wire somewhere, which is also the whole point of having a hardware ALU in your thing, because the carry chain is just faster. I'm trying to see if there's anything suspicious here that would indicate what's happening to the carries. Because basically, okay, let's trace one LUT. This LUT has, like, you would expect it to have an A and B input, and then an output, and like, if there's no carry, they're just independent of every other LUT. Well, if there's a carry, you would expect something to go like from LUT to LUT to LUT to LUT to LUT to the next one. So it seems like this output is just, going straight to the output. So yeah, there's nothing that seems to indicate any sort of carry chain here. And also at the input, they're just straight up coming from here and not doing any. They're not chained through each other basically. They're just going straight from input to output. So it seems as though the carry chains are indeed sort of implicit in the positioning of the lookup tables. What am I even looking for now? Which means, one interesting thing we could try is, what if we make it bigger than, no, wait. Let's see. So like this still fits in one tile, right? This is, no, it doesn't. This is, like 1, 2, 3, 4, 5, 6, 7, 8, which are not used. And this is already the next tile. So somehow the carry goes from one tile to the next, basically. What if you would constrain this one to be all the way at the edge, so that it's forced to not be in one row? Because right now my thought is basically the carry is just sort of implicit between all these slots. I'm just not sure what enables it basically. So like basically, imagine you put this like just as slot bits. So yeah, how do I say this? There should be a difference between just having LUTs with these bits in it and having an ALU, because otherwise there's no carry. So there has to be something that sets, like enables the carry or routes the carry or does something with the carry. Which is what I'm trying to find. So looking at this, there's basically this is all just filled with wires, muxes. There's basically a few empty spaces here, a few empty spaces here, a few empty spaces here. And in particular, this one is suspicious to me because like there's no data flip-flop here. So there has to be something interesting here. I just don't know what it is. Yeah, and also these pixels that are near the flip-flops but not part of the flip-flops. Also weird. Haven't figured that out. I don't know. Maybe this is I'm not, yeah, this is interesting to people to just look at me being confused, or otherwise I'll just like stop here and make another stream when I have some idea what's actually going on. You can type in the chat or something. I am very much at a loss how this works. Yeah, I think I'll stop here and do another stream when I actually know what's going on, where I actually, implement the fuzzer to add this to the database, because yeah, I don't think it's very interesting to just sit here staring at it and not having a clue what's going on. Yeah, so thank you all for stopping by, and I'll let you know when there's progress or when there's a new stream.